In this example, we are going to look at a function that describes the position of a particle along a linear path at a given time t. This is f of t equals t cubed minus 6t squared plus 9t. In this case, t is going to be measured in seconds and f of t in meters. And we think of this linear path as maybe just like a number line. And each of those tick marks on the number line would be 1 meter. So for example, at time t equals 0, which is when you get started, the position of the particle would be given with this function as 0 cubed minus 6 times 0 squared plus 9 times 0. So f of 0 is 0, which means, let me put this here. There we go. At time t equals 0, the particle is at 0 on this, at 0 meters on the number line, which kind of makes sense that in general, we're not necessarily thinking of the path as a number line, but just a general linear path. And so at time 0, we're starting at wherever here is, and then we're going to see how we move along that path as time progresses. So to take just one more example, if I take t equals 5, so at 5 seconds, we have t cubed, 5 cubed is 125, minus 6 times 5 squared, that's minus 150, that's negative 25, and then plus 9 times 5, so negative 25 plus 45 is 20, and if I put in t equals 5, so after 5 seconds, the particle is 20 meters ahead of where it started. Okay, so I'm going to go ahead and set this back to 0, and we are going to press play here and just see the movement of the particle through the first 8 seconds. Okay, so ready? Just go ahead and watch this particle moving along that linear path as I press play. Okay, 3, 2, 1. Okay, so you might have seen that the particle like moved forward and then back and then forward again. And there's a lot of different questions that you might ask, like maybe you ask, how far forward did it go before it came back, and how far back did it go before it turned around and started going forward again? At what time did it move back, and at what time did it turn around and start moving forward again? And you might ask, what was the velocity of the particle at any given time, or when was the particle speeding up or slowing down? These are all great questions, and the challenge here is to use this function as it's described here, this polynomial function, as a way of answering some of those questions and maybe more.